Hello, my dudes and dudettes. We can call it that. Bloody hell, it's a warm day today. Sweating my balls off. I wanted to make this video whatever now. I've been breaking down because I bought a Ford Focus ST Mark III model. And obviously somebody had decided to run it through a heavy puddle. And obviously it gobbled water into its intake and lifted the head. So we've been working on a full engine rebuild on this, and I thought the best thing to do was to be able to buy effectively a short block slash replacement, start with a nice fresh engine block and new crankshaft. I haven't taken the old crankshaft out. The chances are it's probably bent, it's probably spun a rod, and the cylinder is most definitely scored. That can be just sort of seen now. It might be able to be fixed on bores, but we'll get into that a little later in this video as why I've chosen not to have that block machined and rebored. There's a very good reason for that, and we'll get into that. But effectively, this engine that's used in here, which is the r9da or r9dc model engine, is a 2 litre with a piston size of 87.44 millimeters. Now, not very good with the conversion into the imperial side of things, but so I work in metric, of course, on that. I have done for several years. I haven't really used the imperial since 20 years ago, so generally because the UK has been part of the European Union for so long that you know, we've been working on the metric system since sort of the early points after the millennium. So effectively, yes. Now this, to start with, really on this engine, the cylinder actual liners that are used in it are only about 2.5–3 millimeters thick in their wall thickness. That's done primarily to get as much heat so that the cylinder itself, where it's sleeved inside the aluminium block, the water jacket around it can extract as much heat as possible from the cylinder wall. So effectively it's a very thin sleeve cylinder, so when you bore it out from, let's say, the 87.5, which actually as stock isn't 87.5, it's actually, I've measured it through here on all 4 bores, 87.47 millimeters, and it's used for the hyper-eutectic piston that Ford use. So obviously, as I say, a hyper-eutectic piston doesn't expand as much as something like a forged piston. Obviously I'm going to be using a 4016 forged piston in this, so I actually need to ever so slightly bore thousandths of an inch, bore that back out to 87.5. So because the piston 87.44, which is supplied by Wasner Pistons, needs a 0.6 of a millimeter clearance. So that brings us up to a bore of 87.50 exactly. So that needs to be machined out, or should we say honed out, to that size, because it's such a small amount, as I say, that the honing can take that out. No point putting it on a boring machine to take that much material off. So, but effectively that's the sort of situation. Now people have asked me, or there's been a lot of questions I've seen on the internet, as well as people have asked me, what is the difference between the r9da and the r9dc engine. Now the r9da engines are mostly used in things like Jaguars and Land Rovers, and the reason for that is because it has the crankshaft counterbalance unit removed. It's not there, and the reason for that is it gives a much faster, you know, response uptake on your RPM, so you can, you know, the engine rev counter goes up much faster because you've got less drag on the engine. However, for the ST, they sort of designed it more like a luxury sports vehicle on its trim model, so it's generally fitted with the r9dc engine, which actually does have the crankshaft counterbalance unit in the bottom, which are 2 bloody great, you know, sort of crankshafts on their own, sitting in an assembly basically, which is spun by the gear on the crankshaft, and it effectively opposes the vibrating forces, which helps to balance the crankshaft out in a much more smoother, uniform manner, and provides for a much smoother, much comfortable, more less vibrating, drive effectively. Now you can convert the R9da, put the crankshaft counterbalancer back in. However, there's a lot of people who've got the STs who are actually crankshaft counterbalancing deleting, so they're removing it and then they're filling the cap where the oil feed to the little tiny crankshafts it is with a blanking plate, little tiny blanking plate, which is fine. I mean, if you want to do that, you're just converting it from an r9dc engine to an r9da engine, and an r9da engine doesn't come with it, but you can convert an r9da to an r9dc if you do put the crankshaft counterbalancer in, and that's the difference. Now here's the thing: Ford saved a huge amount of money on a lot of areas and a lot of elements on this, the crankshaft being one of them, which is not the strongest crankshaft in the world. So for all you guys out there that are bumping up your tunes without changing crankshafts and things like that, you are running the risk of effectively destroying a crankshaft, destroying rods and rod bearings. So that you've got to pay more attention into that area. But really, the crankshaft in these engines are only good for about 300 to 350 brake horsepower. Anything above that, you're pretty much running the risk of bending these crankshafts. They're not very strong, so an aftermarket crankshaft is probably the way to go if you're going to start pushing to the 400 to 500 brake horsepower elements in this engine, which I really wouldn't advise anybody to do. That's a humongously large amount of power, especially for a street car, and I think really only everybody who's really doing track days and racing heavy is generally that's where your performance figure is going to be, or if you're going to use this engine in a kit car or something like that. So again, you've got to understand what you want your application to be and where you want to take your engine build on this, but there's some very important factors here that we should go into on the engine build of these engines. These engines are built on tight tolerances, and those tight tolerances are governed by the material of the actual conrod itself, the type of piston used, the design in the piston, which we're going to get into in a moment, and that is due to the actual thermal expansion of those materials. Those crankshaft clearances for a stock rod or a Ford Motor Company rod that's used in these engines are quite tight, so you're looking at approximately between 0.15 to effectively 0.16, 0.17 0.017 of tolerances, which are quite fine. I believe they translate in something like a thousandth of an inch, I think. But effectively they're very tight tolerances, and the reason they do that is because they want you to run a 020 oil. This is a fuel economic oil. It's part and parcel of the EU's directive regulation, which is forcing manufacturers in Europe effectively to use thinner oils, much more environmentally friendly oils, the C-type oils, which is C3, C4, C5, catalyst and environmentally clean burning oils. Effectively that's not necessarily very good if you're pushing horsepower, but the thing is, to run those oils they have to push those tolerances much tighter, so effectively the engine wears out quicker. However, they're not interested in how long it takes for the engine to wear out, as long as it covers up to the 70,000 mile mark, and past it's effectively 3 to 5 years of warranty. They don't care. And this is one of the reasons why they're running these tight clearances, to run the thinner oils. And obviously there is a directive to say that the oil companies who manufacture engine oils must get better with their oil to make the engines last longer, and they are starting to get very good. There's no doubt about it. Engine oil technology is definitely massively improved, so 020 oils are actually quite good. They are quite resilient, and you can still get a good period of time of use out the oils. However, a 530 oil is much better in my opinion. As I said, it does tolerate more, it does protect the bearings, journals a lot better, but if you start making modifications, changing the conrods, changing the pistons, things like this, your clearances you can't go by the Ford clearance manual anymore. You must go by the clearance ratings for the manufacturer of rod and piston that you use, because they will expand under heat at a different rate. Now, these engines have suffered from ringland failure, particularly in the earlier models of these engines. However, Ford have addressed that issue, and we'll get into the piston design that Ford's done. Right here I actually have a stock Ford piston with a stock Ford rod, wherever the Fomco stamp is, which is right here. Look, as you can see, there's the Ford Motor Company stamp. Now this is a stock, this has never been run, never been fired, this is brand new out of the Ford straight short block. There's something very special you've got to look at this piston, because basically it was this ringland at the top ring here. Let's move this ring gap around so you can see where that is if you look. So our ring gap is right there, as you can see. And what they did to resolve the initial problems with these hypoeutectic pistons, which were crushing at the top here and flexing too much, it would crush onto this, and then effectively your top compression ring would get stuck and jammed in the ringland. So what Ford have actually done here, which is quite clever actually, is they've put, and if you look very carefully, the ringland actually has a steel, so it's not running on the aluminium hypoeutectic alloy. It's actually got this steel ringland that they've put in there to strengthen up this top ring and resolve the problem. So if you wanted to run the standard stock piston, of course, that would be good. The thing is, the weak portion of the stock Ford is actually the conrod itself. It's a lot slimmer, and this conrod here or whatever expands a lot more than, let's say, a replacement ZRP or Marley conrod. And other points to focus at is these are really cheaply made. Most of your clamshell rod ends on a standard, let me just take this apart and I'll show you. Effectively, and these are also stretch bolts that they use on these. They don't use like the ARP 2000s or anything like that. But if you actually take a look here, there's very little finished machining on these, because these are basically, these caps, they're forged all together, and then what happens is a big massive guillotine comes down and slices these two pieces, and these break off, and then they can only but go back together that way, because, as I say, they don't machine the finishing, or they don't finish off the ends to go flush, and they don't use little inserts. But if you look very carefully, do you see how thin the walls are for the threads and these bolts? I've still got one of the bearing shells obviously in this one, but if you can see, they are very thin walls. So that's an idea, I guess, for them to get the heat away from the bearing journals while they're in operation, but it doesn't leave you much strength. So there's not much strength in these standard stock Ford conrods. However, they have strengthened up the hypoeutectic piston, which is actually quite a good idea, so you could use one of these. But remember, these do not run on an 87.5 bore. They actually run on a slightly tighter bore of 87.476, and these are an 87.44 millimeter skirt to skirt from your measurements. That's not including the coating. The coating probably adds about another 0.02 of a millimeter extra on there, which is designed to effectively protect it as it's running in the piston bore when you first fire it up. But that's basically the standard, what you get when you buy a standard Ford setup effectively on this engine. Now, if you upgrade to a rod like this, which, as you can see, is a much beefier rod, I shall take it out of the packet for you so you can have a look These are actually quite well balanced. I've done the measurement on these. They really don't need anything taking off, but if you can see, this is a much more cleaner, much more beefier rod. We've got an ARP 2000 bolt in either end of the cap. These are actually, they've got the little guide pins inside these, so that, as I say, they clamp together, they stay together perfectly, and they've been very well machined as a rod, and it's a much stronger rod because you can see, as I say, there's much more girth to it there. It's still an I-beam, you know. I don't see the point of actually upgrading to a H-beam in many cases, but as I say, it's straight I-beam, and you can see it's much better manufactured. There's more material around the rod itself, so a much worthier upgrade, you know, particularly on these engines, is to do that. Even if you kept the same pistons with the same bore in a short block, it's best to change the rods. However, once again, pay very close attention to your clearances, and I'll show you why. This manufacturer of rod, in its manual, it has a piece of paper in its box. Take the time to read it, because the clearances have now changed, because that's a completely, totally different composite type forged material. It expands at a different rate. In fact, it actually expands and stays more solid to its thermal expansion. So let me just get you the data sheet, particularly here. On this, as I say, it gives you the different torque settings for the ARP 2000, depending on whether you're using a 5/16, 3/8, 7/16 thread size. You know, you've got the different torques: 30, 45, 45 newton meters, 65 newton meters. The ARP L19, which is the weird material that you must never get wet. It must always be oiled, you know, otherwise it gets this dynamic thing going on. Basically it corrodes it and produces hydrogen. That's the L19s. They torque to 50 newton meters on a 3/8 thread. But importantly, at the bottom here we have the clearances notice. So for these rods, the connecting rod bearing to crankshaft clearance should be 0.02 of an inch, which is 0.05 millimeters of clearance. The minimum, and 0.03 of an inch, which is 0.07 millimeters of a maximum clearance. Now obviously on a turboed engine you kind of want to have a bigger clearance because it is turboed. And it completely depends on how much turbo pressure you're going to be planning to put through this. But again, I wouldn't advise, unless you're changing the crankshaft and everything else like that, I wouldn't advise trying to push it anything over 350 anyway. 300 to 320 is perfectly fine, I think, for anybody who's running a street car. Anything more than that is kind of unusable really on roads. But you know, you've also got your recommended wrist pin clearance. Now you can measure that to say they usually fit perfectly for the manufacturer's standard wrist pin or gudgeon pin, however you want to pronounce it. The Wasner pistons are ground specifically and precisely to that size of the standard manufacturers, so you know the little end bearing on these will work in the standard hypoeutectic piston gudgeon pin, as well as they would in any upgraded piston you use. So that's not really necessarily a concern, but it's also good to check it to make sure it is. So use your bore gauges, use your micrometers to make sure of that, just to clarify, because you never know, you might have a faulty part from the manufacturer, which I've had before, you know, it has happened. But the big thing here is to make sure you get clearances. Do not follow the Ford's technical manual on this. Follow the rod manufacturer's data that you've purchased for, whether it be Marley, whether it be Wisco, whoever it is that you bought, whatever manufacturer the rods. Check their data, not the Ford instruction manual. Again, different materials, they're manufactured in a different weight, different style of material. They're using a different clamping bolt, such as these are designed to work closely with the ARP 2000 bolts. So Again, you have to use the ARP thread lubricant on these, and also on the base of the bearing face of the bolts. So again, you've got to pay very close attention to that, follow their guidelines on it. The more turbo boost you run in, work towards the higher the gap, but if you're going to be running those higher gaps, you're going to have to change the oil viscosity as well. So if you're going to be running a 530, but you're going to be running close to the bigger gaps with a higher boost, you've got to start moving up to, let's say, a 540, or even possibly something like a 550, something like that, with a higher hot temperature viscosity, to try, to keep that gap closed up and an oil film producing on top of it. So things to bear in mind. So if you choose the tighter of the clearances or whatever, you can run a thinner oil, but I wouldn't go anything more or less than 530. In fact, actually a 540 towards the tighter clearances is better, and obviously towards the larger clearances on your journal conrod bearings, I'd run something like a 550. What you've also got to bear in mind is that if you do not change and you do not size the crankshaft properly, obviously you start moving up those oils for your conrods, you're going to start screwing up the main bearing journals. The main bearing journals are standard stock or whatever on the stock bearings, and stock sizes will tolerate 530 quite happily. It's not an issue for them, and you also get a lot more it's more resilient, particularly at high temperatures, especially if you're using a PAO oil, which is a fully synthetic blend of motor oil. Mobil 1 do them, AMSOIL do them, those sort of things. PAO oils handle a lot higher temperatures, and that's generally what you need when you're running a turbo, because that oil is going through a turbo, and that oil is getting hot. So you might not think, well, it's not going to get that hot very much in the crank, but it's draining back from the turbo, and the turbo is right there where you've got your exhaust fumes. So you might well be exceeding 150 degrees Celsius at some points, depending on how high you RPM the engine. If you're going to do 100 miles an hour or whatever, not that I'm saying that you should do, because that's obviously illegal, then your RPM is going to be higher than 3000 RPM for a good longer period of time than technically normal driving would permit. So that could heat your oil up closer towards the 150 degrees Celsius mark, which is well over 220 Fahrenheit. And the only oils I know of to date that can stand that temperature for longer duration period of time are the PAOs, or polyalphaonic olefins oils, which are the real fully synthetics, or gas, which are produced from natural gas rather than crude oil, and or the ester blend of oils, which are the as in group 4 and group 5 base oils. So really you should be running those, and obviously make sure it is an SP or an API SP grade oil, because the SP grade oils are specifically designed to stop low speed pre-ignition. So they have a lot of the calcium and sulfites that are normally found in pre-grade oils, such as the SN and SL, SM oils. They had a lot of detergents in them, which has been found to cause a lot of low speed pre-ignition, which will cause the head to be lifted. Which brings us over to the actual strength of the bolts that hold this cylinder head down. They are torsion bolts, and I have one of them here. These are the standard stock Ford type stretch bolts, as you can see. Nice big long thread to go down there. Now what these do, these are kind of like spring steel, to understand that when you torque these down, they ever so slightly stretch, and effectively it's that stretch, like a very taut spring tension, that holds the head down, but they can still stretch more. So if you, let's say, get a fueling issue, like in my case, the previous owner of this car ran it through a bloody heavy puddle and filled the number 1 cylinder with water, and effectively lifted the head, because these spring, they're a torsion bolt, and the head's lifted, it's took out the gasket, and obviously left scoring in the cylinder bore. So if you're going to start running power, you've got to be changing these and go for the ARP studs. Now, I've ordered the ARP studs, however, it's been 3 weeks already and I'm still waiting on them to arrive. I think they're coming direct from America, which is why they're taking forever. But hopefully when they arrive or whatever, I can install the ARP stud kit instead, which hasn't got very much flex to it at all. It takes a hell of a lot of pressure to get those bolts to flex and or break. They're a very good torsion bolt rather than a stretch bolt, which is the best upgrade you can do to maintain your engine, which doesn't change the OE spec. I don't care what anybody's going to turn around and say. If you change the standard stock bolts to an ARP bolt, it is not changing the spec of the engine, it's not improving performance, it is not making a bigger horsepower, it literally is just improving the reliability of your engine, which as far as I'm concerned is a damn good thing, not a bad thing. So, you know, all those weird guys out there saying, you shouldn't report it to your insurance company, it's a modification. No, it isn't. It's an actual normal standard replacement and improving the strength of the engine. However, will the insurance company cover it? If you ever get into, if somebody else bumps you or whatever happens, will the insurance cover it and supply you with a replacement car that has ARP bolts in it? Probably not. So that might be a thing to be reported to the insurance company so that they do, but that's about it. You know, these are not a spec changer, you know. However, deleting the crankshaft counterbalance unit, that could be on a modification because that does improve performance. It changes the spec that it came out with. But if you've got a Land Rover or you've got a Jaguar, that doesn't matter anyway because they don't come with the countershaft balancer anyway. So, so that's the cylinder bolts, that's your cylinder head. They suffer from head lift all the time, primarily because the bloody OE stock bolts are crap. You know, I said it, you know, they're crap, you know. So one of the best upgrades you can do to these engines is to move to an ARP stud kit. Now the bottom end crank, main bearing bolts, they're exactly the same, they're torsion stretch bolts. And you could move to a stud kit at the bottom, that would even more improve it. The problem is though that the standard stock Ford crankshaft can't deal with that pressure. So I don't know whether it's worth moving to those when you've got a standard stock crankshaft. I suppose you would want to move to those if you're going to be moving to a high performance crankshaft possibly. But you know, I mean, that's another thing, and I suppose that's a discussion for bottom end, you know, workings and builds. But effectively you've got to make sure your clearance is on this. Now obviously I'm going to be using Wasner 87.44 forged 4016 pistons. The reason I've chose 4016 pistons is again because they don't expand as much as a 2032. 2032s will cause a tremendously large amount of piston slap. They're really only good for a racetrack and super high performance. So if you are pushing over 400 into 500 brake horsepower regions, then yeah, I suppose you would do that. But on a cold, very cold morning or whatever on a street car, you fire that engine up, you'll be they'll be fucking rattling around in there until the engine warms up, because they take a, you know, they expand a lot. So the 4016s are better. They're a strong, a lightweight alloy piston, and you save a tremendously large amount of fuel economy because you're reducing a lot of weight. These I-beam rods are much heavier than the stock because there's more material on them, so there's a stronger rod. However, it's made up with that by the lightness of the forged piston. Very important to run the right engine oils in these because, like we've said, clearances, the tolerances, you've got to set those. Don't guess them, you have to set them. You know, you have to set the piston clearances. You can't guess them, they have to be perfect. If you go and put a 4016 piston in a bore like this, which is too tight by 87.476 millimeters, it's just too tight, that piston will expand too rapidly. It will destroy itself on the cylinder wall, possibly even seize the engine. It's not a good idea, it's not a very clever move. If you think that the piston rings are going to wear out that thousandths of an inch, If you're lucky, it might do, but what you're going to be doing is you're going to be producing more heat in the cylinder bore, which is going to expand your rings much higher than the actual manufacturer's tolerances for your piston ring gap, and probably score and destroy the piston cylinder before it even wears into that situation. So make sure you get your clearances right. Follow the manufacturer's recommendations and sizes. And when I say manufacturers' recommendations and sizes, I'm not talking about Ford's, because Ford's manufacturers' clearances and sizes are set for their parts, which is a hyper-eutectic piston with a steel ringland and these thin, very thin-walled conrods, or should we say cast conrods. So if you use that, then yeah, by all means carry on with the Ford Tech manual. But when you're using aftermarket parts, especially conrods and pistons, use the data provided by the manufacturers of that part's recommendations. And obviously on here, these ones are quite large clearances for these rods, you know. Now these people make these conrods, they know how much the thermal expansion is going to be, they know how much it's going to expand and contract under heat cycles and heat soak. So you've got to go by that, otherwise you'll end up spinning a bearing. And it doesn't matter, these ones on here are tagged. As you can see that, you can see the grooves here, this is tagged. Those tags are not there to hold the bearing, stopping it from spinning. It will make absolutely no difference. If this overheats and these clearances are too tight, it makes contact with that journal, it will spin. It'll just tear out the little location tag, just tear it out and just destroy the big end bearing, just completely wipe it out. So, you know, the tags are not there to, you know, stop it from spinning. It's the clamping force between these two that does that. It's a controversial subject whether you should put oil on the back of these as you assemble them or not, you know. I mean, yeah, there's some people say you shouldn't, it should be completely dry fit. Some people say that you should put oil on the back of it as well, you know, but effectively it's the clamping torque of the cap onto the end of the rod that effectively holds that bearing in place. But that bearing in place won't stay in place if you get contact between the bearing and the journal. It's guaranteed it will just be destroyed, you know. I use King bearings. A lot of people swear by King bearings. I also do as well. I use two sets. Sometimes I have to use this is a standard Xbox. I have the standards over there in the box, but I use these. These have a special coating on them, which is a much more malleable coating. So if it does, in the event that something goes on and it does come into contact with the actual journal of the crankshaft, it's the bearing that gets sacrificed, not the conrod or the crankshaft journal, which it's a clever layered technology they do. But yeah, you could be under there changing bearings again because they've come into contact with, you know, etc, etc, etc. But yeah, main bearings are not. We're not talking about that in this video. We're just covering the differences basically between the r9da and the r9dc engine used in the Ford Focus Mark III, ST, all the way through Jaguar models and Land Rover models which use the same 2-litre engine. But as I said, if you are going to run heavy boost, or change the turbo to a bigger turbo to push greater beyond 300 brake horsepower, don't go over 350 if you've got any setup like this. You're going to have to change a tremendously large amount. I wouldn't necessarily use a 4060 forged piston in anything up to 400, over 400 brake horsepower. Really, for those guys who are pushing 550, 600 brake horsepower, yeah, you're going to have a floppy piston while it's cold and use a 2032. You're going to have to, because obviously the silicon content that's placed in 4016 does make it more brittle, and it will smash, you know. If you start really pushing heavy explosions in there, something may happen and it will just smash the piston into a million pieces. Not necessarily a pretty sight, but if you run more of a normal street kind of vehicle, and you know, lower RPMs, the engine won't really ever see anything more than, let's say, 5,000 RPM, probably on a blip of a throttle, bit of a fun round a country road or something like that. A 4016 piston's perfectly fine, but bear in mind you've got to get your clearance between the piston and the cylinder wall correct. Obviously your revs and upkeep and the sort of the drivability of the engine will be improved by changing that piston, because with Ford putting this steel ring in there, it does make it a very heavy piston. You know, but it is a good strong piston, and there's nothing, I wouldn't say anything against the fact that if you were to take one of these out, change the conrod, you know, to a good, you know, stronger, solid, more balanced conrod, and then use the stock pistons back in there. I don't see that that would be any problem, because, as I say, you do have a very strong ring land in there. It's just, if you've got the engine apart and you wanted to add that bit of a performance, I don't see why you wouldn't want to change the piston anyway. But do bear in mind you are going to have to change the cylinder bore size, because obviously I'm approximately thousandths of an inch, is it? I think that's the Imperial one, about 0.02 ish off, something like that. So yeah, you're going to have to take that very fine small amount off. Don't rely on the piston rings wearing that size out. As I said, it probably sees within 5 minutes of running the engine before it'll even get to that stage to take material out. So make sure you get your clearances right. But as I said, this piston, if you look at the quality of it, you could whack this one straight back in, to be fair. Just change the conrod and then run the new manufacturer's clearances on the bearing journal instead of the Ford's one, you know. Again, Ford do it because it's the oil viscosity. They got an EU regulative mandate that pushes Ford to have to use more fuel economic, more environmentally friendly oils, which are the 0W20s, even the 0W16s, which they're trying to push a lot of manufacturers into. And these oils are very thin, and I mean they're absolutely brilliant for fuel economy, but if you're going to try and run any kind of boost or any kind of heavier usage on them, those oils are too thin. They're also very too thin for the camshaft lobes hitting on the flat, the flat tappets basically. You know, you need more of a stronger oil film on those. However, the technology in those thinner oils is getting better, there's no doubt about it. The problem is that certain elements in those oils are having to be removed because they need to burn cleaner, which does make the oil weaker. It's not good for the camshaft. So how do you do it? It's a balance between protecting the environment and fuel economy versus engine wear. And the thing is, it's the cost of engine wear that they're doing, because it's not a cost to them, it's a cost to the owner of the vehicle. So it's but it's a balancing act between it. So just remember, bigger clearances, thicker oil. So 530s and 540s. When you're moving these, do change your oils. If you still run by the stocks and you go by what you put in the number plate at Halfords after you've modified an engine like this, and if at Halfords says 0W20 will work, but you've gone and opened the clearances up because you've put in these new rods, then you're going to run into problems, you know. So bear that in mind. I think Driven, I think it is, their website actually has in their catalogue a list of bearing clearances to oil weights and also how to calculate it if the engine's boosted with a turbo. And I believe on their gauge tolerances, which run up to 0.02 of an inch, which is like 0.48 or 0.5, I believe. They're on 540, I believe they want you to run. So if you run it on the tighter ones of here, which again as stated in here is 0.04 of a millimeter minimum, which is just under, I believe, 0.02 of an inch, and the maximum, yeah, hang on, no, I'm looking at the recommended clearance for the little end bearing, connecting rod bearing crankshaft clearances, 0.02 of an inch, which is 0.05, so that is 0.02 of an inch, I believe, and the maximum here is 0.03 of an inch, which is 0.07. So if you're going to run heavy boost, then you'd be over at the 0.07 of a millimeter. I'm sorry for missing the zero out. It's the millimeters to inches conversion thing confuses everybody. But I mean, for me, I'd say 0.07 of a millimeter or 0.03 of an inch is actually quite big. The journal sizes on the bottom of these, on these cranks, standard from Ford, are about 51 millimeter, which effectively is 2 inch, or approximately 2 inches. So that's 0.02 of an inch clearance by your old rule of thumb. Manufacturer is saying, you know, between 0.4. Now, if you're going to run like I suppose if you're going to want to run a 0.20. You really want to have that clearance there at 0.04 of a millimeter. That's the tightest recommended by the this manufacturer of Conrod. So, you know, I mean, for me, as I said, it kind of in the middle, possibly 535, 40 weights, because turbocharged applications do get some blow by, and it will dilute the oil. So you'll be going from a 540 to a 530 effectively. After a short period of time anyway, so it will probably be better maybe in this case, because it's the minimum and maximum, go 0.5, which is 0.02 of an inch, or thereabouts, because 0.048 is actually 0.02 of an inch, I believe. So 0.05 is slightly over 0.02 of an inch. So, and obviously the minimum they're saying here is, again, on the Conrod, yeah, 0.05, yeah. So that is just slightly bigger than 0.02 of an inch. But yes, again, these are. It depends on the oil running. Have a look at the chart. Driven's got it in their catalogue. I think it's it's in the 30s, 34, 35, 36. Somewhere like that, or whatever. They have a listing in there telling you clearances versus oil viscosity at certain temperatures. And obviously if you're running a turbo, you're pretty much going to be on a very hot temperature oil. It could be well up to 100, 150 degrees Celsius on that oil coming out of that turbo. If you've got an oil cooler on there, you can certainly cool that down a little bit, but your oil viscosity is going to be pretty thin. You're going to be running higher clearances, obviously, so sometimes better to eye it on the sense of caution, and actually a thicker oil like a 5W40 actually might be the best way to go, depending on your driving style, because if you're going to sit there at over 3000 RPM for a good length of time, there's a possibility that that oil may reach 120, 130 degrees Celsius, because it's running through the turbo. So you got to think about that. There's a lot of elements involved, but anyway, enough of this rant on this video. Just wanted to go through a few certain things and failure points on these Ford engines, which effectively is cylinder head bolts are absolutely crap. I said it, they are crap. Okay, change to an ARP cylinder head studs. It's absolute bare minimum to keep that cylinder head planted down. Secondly, it used to be the piston ringlands. However, the new update that Ford has done with these new hypoeutectic pistons, whatever, seems to have addressed that area with a steel ringland, which seems to be a pretty good move by them. So But the second weakest point on here, unfortunately, is the crankshaft and its conrod bearings, or its conrod, shall we say. They have a tendency, especially when you're running power or at high RPMs, to grab the bearing and spin. You know, so working on the improvement of there, which is three elements on it, is always a good idea for these engines. And other than that, as I say, it's a very strong engine. But if you don't plan on giving it the heavy beans and the heavy boost, you know, every time you're driving, just sort of, you know, drive it normally type thing, there's not really any point in doing any of this anyway. You know, but you know, you can never go wrong with the ARP stud kit. That's definitely the best upgrade you can do on one of these engines to make it a little bit more reliable. But that's it. So I just wanted to share that with you across here. But yeah, the r9da versus the r9dc, we've covered it. Covered obviously certain failure points. So yeah, all good. So this is all for me for today on this video. I've been rambling a long bloody time. A lot of information there to cover. Hopefully you can digest it and this, that, and the rest of it. Leave comments below. Obviously try and be nice and whatever. Don't want anybody starting a, you know, fight with anybody down there and getting abusive and threatening behaviour. We don't want that. As I say, YouTube and Facebook is not. That's not what it's for, and that's not what this video is for. So be nice. Take it easy, guys, and subscribe, and feel free to comment. Take it easy. See you later.